So before we start, I'll share my briefly about myself. So I am Sumit. I lead Analytics Labs. I co-founded Analytics Labs in 2011. Some of you may have already interacted with me in past. Many of you would be doing it today, and of course, in the due course of action as you progress through the course at Analytics Labs. So overall, I have about 15 years of experience now, which has been throughout in analytics and data science. Fortunately, have been part of this industry right from the very beginning, when most of the analytics was limited to Excel, SPSS, SQL. Some of these tools you may not even hear about them now. But I've seen the journey of analytics through big data to when the term big data, data science, data scientist, they were coined. And of course, how world moved from one platform to the other. However, the fundamental concept of analytics or data science remained same. It's just that became much more powerful to suit the present day business context. So a lot of things which I would be talking about today would be in the direction that I can help you understand about data science in more practical sense. That you can, when you think of data science, you do not just think about it as a term or a job role or just a career option, but how does it contribute? What does it work at the back end? Why it is so important for the businesses? We have some agenda, which I'll be just talking about right after this slide. But one thing we would want everyone to participate in the session. When I say participate, it could be sharing your thoughts if you're talking about any concepts you already know about it. Or for that matter, if you have any doubts related to that, do not hesitate, because key thing about this class one is we are going to use this as an orientation session, which helps you to develop understanding. And as you progress through the course, you know in what direction and why we are moving in that direction. So broadly, the agenda today will be focused on discussing what is data science in terms of definition and what are the different things it entails. What are the different stages and types of analytics? This is very important to understand at this stage. Who is a data scientist in terms of role? What does a data scientist do? What are the key skills one needs to have to succeed in the role of data scientist? Then at this point of time, when we talk about data science, we understand it at a very broader level. We also will take a step down to understand about data science from enterprise level, because data science, when we understand from enterprise point of view, there are multiple pieces which move in tandem for any data science project to succeed. Then going beyond the role of data scientist, because in the field of data science, apart from data scientists, there are many other important job roles, and they are interconnected. When you start your career, you may be starting your career as data scientist, you might be starting your career as data analyst, business analyst. So all those things are important to understand. Then there is a topic of ML ops, which we may pass for today, and we will be covering it in the later sessions, because generally in session one, if we have good amount of questions, which I really encourage, we may not have time to cover this. However, this part you would be anyway covering as you progress to your data science and machine learning modules. Seventh, the popular certification courses which we have. Many of you have enrolled for 2 or 3 main learning tracks, but in session one, we would also give some walkthrough on important difference against different learning tracks, because in the initial phase, you have an option to upgrade into different learning tracks if you feel the need. So that's broadly the agenda. But as I said, this is a broader agenda. Very happy to answer as many questions we can take and help you to develop a practical understanding of this field. Now, what is data science? So one can find variety of definitions around it, right? Some of the things you may already understand about it. But I would love to hear more from you also, as per your understanding. Forget about the definition we have on the screen. We'll come to that. But if I ask you, what is data science? What comes to your mind? How do you define it? Anyone, guys?
Structuring of data.
Okay.
Yeah, an unstructured data into a structured data.
Okay.
Analyze the data and do some operations through the data science.
And converting into a meaningful structured form for job for its value, like getting trends out of it.
Okay.
Kind of.
So the key things I'm hearing is applying science to data to derive insights. Okay, deriving insights is very important. Making sense through data, similar like insights. Some of you also talked about structured, unstructured data. Yes, that's true. Anything else?
Field of study that uses raw data for new ways of modeling data.
Okay, modeling data. Yeah, using various techniques.
Like data-driven decisions,
Right.
data designs.
Right. Okay. Then I also see one answer from Anandu, which is on tools to organize data to derive meaningful insights. So meaningful insights we have already talked about. Tools, yes, we all understand. But one very important aspect of is organize, because most of the times the data we get needs to be organized, pre-processed before we can do anything which is meaningful. So collectively, if I hear all these things and we put it together, we are talking about dealing with structured and unstructured data, organizing it, using various techniques, tools, methods to derive insights from it. Yes. So one of the simplest definitions which I like to stick to is to gain insights into data through computation, statistics, and visualization. One thing which we may want to add sometimes, that is to drive smart business decisions. Because as you said, we are using various kind of techniques, tools. They can be broken down into computation methods, statistical methods, visualization methods. If we combine computation and statistical methods, you may also call it as machine learning, right? But there is a very big objective behind it, that is to meet some business goals, to help organizations to gain some insights which help them either to, let's say, improve business decisions, business performance, customer satisfaction, increase their revenue, increase their profitability. So whenever we are leveraging data science or trying to develop a solution from data science, there has to be a business or organizational goal to it. So that is the central piece which we must not forget. The other thing I would want to emphasize is, so Hal Varian came up with this thing a few years back, that ability to take data, to able to understand it, process it, to extract value from it, visualize it, and communicate it is going to be hugely important skill in next decades. Not only at professional level, but even at educational level for elementary school kids for high school kids, for college kids, because now we really do have to essentially free and ubiquitous data. So if we see this term ubiquitous data, this is true in every sense. So wherever we see, whatever we do, we are actually generating the data, or we are being part of data generation directly or indirectly. Even when you are buying a cup of coffee at any coffee shop like Starbucks or CCD, you are generating the data. Whether you are doing a cash transaction, then also coffee chain is storing the information about you, maybe using as loyalty cards, loyalty points, or even if you're swiping your debit card, credit card to buy a cup of coffee, then also you're generating the data. At that time, you're generating the data both for bank and for the coffee chain. Now, what is happening is, because of data all around us, many business functions, almost all business functions, are ever increasingly becoming data driven. To the extent that even if you do not want to be, let's say, a data scientist, but having knowledge of data analytics is very important. Or let's say some level of understanding is expected, whether you are a marketing professional, whether you're a sales professional, whether you are into operations. You would see, if you are already not experiencing this, that going forward, some data education, data science, or analytics literacy is expected from all these roles. If you have kept an eye on how education is evolving even in our country, in 2020, Government of India came up with National Education Policy, where even from 5th standard onward, kids are being now exposed to machine learning concepts, data related concepts. So the point which I'm trying to make is, you do not learn data science just to be a data scientist, but you need to be now a professional who is data literate, analytics literate. So that's a very important piece. Sooner we realize we adopt to, faster it will help us to get ahead in the professional career. Now, coming back to the definition of data science, we talked about it. However, in the reading document, we will also share this with you, a blog we have where you have different aspects and much more, many type of other definitions available. But for our context, I think this helps us to understand the crux. Anyone has doubts on what we just talked about, that what is data science? Okay. Now, another important concept, or I would say misconception, many businesses and many people expect data science to work like a magic wand, that, okay, if we are using data science or AI, overnight we'll reap the benefits out of it, or I can learn data science in, let's say, 1 week and be ready to be a data scientist. No. So from both point of view, whether you are aspiring to be a data scientist or data science professional, or you are someone who manages teams and businesses and thinking about leveraging data science, it's important to understand that data science is a process. In this process, we have several steps involved. And meticulously, we have to go through these steps as a team, as a business, or as a professional. We have to perform these steps. So I'll give you an overview about these right now. Of course, you will be understanding each of this in great detail as you progress through the course. One is setting up the goal. So it could be a research goal or it could be a business goal. As I said in the definition part also, that data science without a business objective or goal does not help. Second thing is retrieving data. So let's say we know what are we trying to achieve from a data science project or analytics project. Now we also need to understand what type of data we need. So sometimes we may have this data internally, sometimes we may have to get data externally. And as some of you talked about this, that data could be structured or unstructured. Now, more often than not, when you get the data, that data is not usable directly for any business purposes. There is a very important stage in the data science process, that is data preparation. So typically your data may have a lot of errors, or let's say impossible values. For example, you have a date like 30th February in your data, which is of course wrong date, right? Or let's say a year is recorded as 1930 when the business or that bank, or let's say that coffee shop was not even established, right? So typically when you start dealing with the data, you may have a lot of errors, missing values, outliers, very huge values. Let's say it's a customer survey data, and it's some customer has input their monthly income as $5 million. So we know it's an outlier value that can't be possible. So all these kind of things have to be dealt with. There are many more nuances to it, which of course, when you learn through different modules, you will be working on. But in short, this step is extremely important, because whatever we do next, if this step is not done right, the output is never going to be right. So a lot of initial modules, initial classes, you will actually spend on data preparation. Once the data preparation is done, then we move to data exploration. We may draw some simple graphs, some combined graphs, some non-graphical techniques like maybe some tables, EDA tables, etc., just to understand that what kind of information our variables contain. Do we have some information which is useful? Do we have information which is not making any sense? Because at this stage, it's possible we may be able to identify that what data is making sense and what data is not making sense, or what part of data could be of higher importance and what kind of data may not be that much importance for us. Then comes the data modeling. Now, this is also something many of you talked about. But you would see as part of the process, this comes much later. This is extremely important and central to the whole thing. However, it comes much later because, as I said, if we have not done the previous steps right, my data modeling will not succeed. So when we say data modeling, it could be your statistical models, machine learning models, AI deep learning models. So a lot of information we have gained till this step, data exploration step, will help us to pick up the right set of models and refine them for the final outcomes. Even once the models are done, it's important that we diagnose those models, that are they making business sense? It is possible you are doing some predictive analytics. You are using these models to make predictions, but the output which we got is not making business sense. My business leaders, stakeholders may not accept that outcome. Do you have very solid reason to believe that? Or is there any error in the model because of which you might be getting counterintuitive results? So model building, execution, model diagnostic comparison, once all this is done and we are satisfied with the outcomes, typically, we present this data or the outcome or the results to our stakeholders, business stakeholders. Sometimes it could be your external clients, sometimes it could be your internal business leaders. And these days, a lot of automation is coming into picture, that once the model or modeling is done, you will have ML engineers or AI engineers who will further take up that model and build a solution, automated solution out of it. So all in all, if we broadly look at this, there are 6 different steps in the data science process. Within each, there are many granular steps, which of course, as part of this class, we can't discuss too much in detail. As I said, you will be learning all of these things, but hope you get an overall idea that why we say that data science is a process, that kind of things which it entails to succeed or to complete one data science project. Again, for your reference, we have a blog which explains all these things in good detail. This also will be shared with you. But anything I can help you to clarify or anything where you have doubts, I am happy to elaborate or share it with more examples. All good? Great. Okay. So in case you get any doubts related to this at any subsequent slide which might be related to this, happy to take at that stage as well. Now the next thing is stages of analytics. I am going to break this down into two parts. First, we'll understand broadly the 3 stages of analytics. Then we'll go a step further and we'll break it down, these 3 into 5 stages of analytics. Okay. And for this, we'll understand 3 different types to begin with. And we'll take one example here. It could be an example of, let's say, online e-commerce, or it could be an example from, let's say, cab booking app, right? Both are my favorite examples. So let's do one thing. Let's take an example from Uber, right? So the first stage of analytics is descriptive analytics, which helps businesses to understand what has happened so far. So this type of analytics is most basic, but extremely important, because we need this type of analytics even to go further into the advanced stages. So for example, if Uber wants to understand how satisfied are their customers, how is their revenue, how is their business performing this versus last year, right? Where is the company bleeding the revenues? So if you look at it right now, we have talked about 3 very simple questions. All these 3 questions are backward looking, that what has happened so far. Okay. Now, the type of question can be more complex. The nature of the question would be still same, right? For example, the question which Uber might want to get answer is, how much revenue we are getting from small car rides versus sedan versus large car rides across 3 different type of cities in India, tier 1, tier 2, tier 3, right? Or for which type of rides we are giving highest discount and our profits are negative. So the question could be very basic, or the question could be very sophisticated with multiple parts to it, which I just explained. But still, the type of analysis we would be doing here would be backward looking. Most of the time, here we do not need any fancy techniques like statistical or machine learning techniques. Most of the time, we can use reporting analytics, aggregation, summarizing the data using tools like Excel, SQL, Tableau, Power BI, etc. And that does the job. And another term which is interchangeably used for descriptive analytics is, let's say, business intelligence, reporting and dashboarding, reporting analytics, which is often described as part of descriptive analytics only. So I hope the examples which I shared here, that makes sense. Let me now extend this example to the second stage, where let's say once the businesses have understood the past performance, they want a peek into the future outcomes, that how the business is likely to perform in next 6 months. So for example, they understood how many satisfied or dissatisfied customers they have, but they want to understand how many dissatisfied customers will leave or stop using their services in next 6 months. Which of the customers who booked the ride on the credit card may not complete their payment after the first ride? Do we have enough support staff to answer the incoming calls in next 1 quarter, 2 quarters, 3 quarters, right? So what has happened here, the nature of the question which we are trying to answer for the business is now forward looking. We understood the past pattern. Now we would be using some statistical methods, machine learning methods, statistical modeling to answer these questions, which are more forward-looking and futuristic. And at this stage, we start involving tools like R, Python, which have more capability in terms of statistical techniques, machine learning techniques, etc. Right. So before I move to the third stage, I would want to hear your thoughts. Any questions you have? Do you understand the difference between descriptive versus predictive? Okay. Great. In case anyone has doubts, please do not hesitate to ask. Because in the third stage, I would now expect some answers from you guys also. So, sure. So Bunty, I'll be happy to answer this. We are automatically answering this part in one of the sections where we are talking about different kind of job roles in analytics. So please bear with me for some more time. I'll answer this question in detail, right? However, to briefly answer your question, when the job role in data science is mostly related to descriptive analytics and may have some predictive analytics or may not have any predictive analytics, that is basically most of the times we are talking about data analytics. So in data analytics, we are fundamentally using simpler tools and techniques to give the business answers. Most of the time, these business questions, business answers are backward looking or descriptive in nature. However, in data science, we start dealing with unstructured data, text data, etc. We also start using more sophisticated techniques like machine learning, statistical modeling, predictive modeling. That's where data science starts playing the dominant role. But as I said, we will understand this in more detail. But since we were on this slide, I'm briefly answering this, you're drawing the comparison between these two. Okay. The third type is, once we understand what has happened, what could happen next, we'll also understand, or businesses definitely want to understand that what should they do? What is the next course of action? So for example, let's say they understand that there are 10,000 customers who are at risk of leaving or stop using Uber app. And they have 1 million budget from the management to use for the customer retention. Now, what is the best way to use this 1 million budget? Because it's possible they may not be able to stock all 10,000 customers. So how should they prioritize which customers to reach and how to address their concern? How to best optimize this budget so that they can retain most of the customers, or let's say the most valuable customers, right? Or sometimes it could be, how do you increase customer satisfaction? So for example, pricing. If they are offering Uber right at very expensive price, customers may not be happy. At the same time, if they're offering at a very low price, that may hit their profitability or operations, right? Now, you see the Uber's prices fluctuate. So there is a lot of analytics which is going at the back end. And most of the time that analytics is prescriptive in nature, that based on the demand, customer value, time of the day, city, place, it will calculate what price it should be charging at that point of time from the customer. So in short, your analytics is helping you to decide the best course of action, or what is the optimum course to take out of 3 or 5 or 10 different options which you can execute. Now, in this case, along with machine learning, we also sometimes start using optimization, or there are some advanced ML techniques related to, let's say, reinforcement learning, etc., which one may use. And typically, to reach this stage of prescriptive analytics, by the time businesses are mature or advanced to use prescriptive analytics, they're also dealing with very high volume of data, where along with your Python R, you also have to back it with some big data analytics engines like Spark. Mahout is obsolete, more or less obsolete, but cloud computing or Spark-based streaming for this stage. Now, I want you to think about another example where prescriptive analytics is used. And trust me, day in, day out, you guys are actually highly exposed to one such example, whether you are on YouTube, whether you are on Amazon or any other shopping website. There at the back end, prescriptive analytics is doing a lot of work for you. Can anyone guess what I'm talking about?
Recommendation.
Exactly. So guys, recommendation engine is a very common term. However, it can have various forms and sophistication. So when you see suggestions from Amazon, what you may like to buy, or people who bought this also bought this, that's also a recommendation engine, that based on customers like you in past, what they have done based on their age group, your gender, the kind of brands you like, it will come up with recommendations to increase the sales. The other example of recommendation engine would be what you see on YouTube, that someone who heard this, listened to this song, also like to watch this video. And trust me, these days they are highly sophisticated and accurate in their suggestions. The third example would be, I'm sharing the examples which work very effectively, is Netflix. So Netflix engine is one of the leading in industry when it comes to suggest whether something for binge watching or for high user engagement, that it shows you the percentage of likelihood that you will like this program or this series. So all these are examples of your prescriptive analytics. Another example which you might want to think about is Google Maps. So from going from point A to point B, there could be 3 or 5, or let's say more than 5 different routes. It automatically picks up the suggestion which is most optimum in terms of time and traffic. So all that is part of your prescriptive analytics. So any questions, guys, till this stage? Do we understand all this well?
Good evening, sir. Good evening.
Yeah, good evening.
Hello. So I would like to understand how the process of data science and the stages compare, like how correlate to each other when they are in the working.
Can you be a bit louder, please?
Uh, Hello, can you hear
Yes,
me, sir?
I can hear
So
you,
I
but
would,
we are moving in between. Yeah.
so I would like to know how the process of data science and the stages of analytics, like how they work together. Like how is it like the whole process works, like according to
Sure,
the stages.
sure. Good question. I'll be able to answer it to limited detail as of now, but this is a question you must actually keep it for later as we progress through the course. See, if you see descriptive analytics, it is actually involved in all the stages of data science process from here to here, right? So whether I am doing a project where statistical or predictive or machine learning modeling is involved or not involved, but these four part of the processes would be definitely done. And that is one of the reasons I said descriptive analytics is extremely important, because even let's say if you're going on a project which is more advanced in nature, right? A simple predictive analytics project will need data modeling, yes, but it will also need all these four steps. At the same time, if I'm talking about prescriptive analytics, because prescriptive analytics typically needs automation, if your objective is just to identify that out of dissatisfied customers, how many may leave in next 6 months, you may not go up to the automation stage or implementation stage. You may limit here, but then also you need descriptive. If you are doing prescriptive analytics where typically automation will come into picture, just the examples we talked about, then also if you see, even when the predictive is coming into picture, your descriptive is always going to be there, because even once you have done the model, if you have to check that model on past data and all that, you can't escape the descriptive analytics. So what happens is, when we start with any analytics project, and even if that project is very advanced in nature, it goes up to, let's say, this stage, which I will be talking about, your steps or the process involved passes through like this only. That to move up to the value chain, you definitely need to have a solid bedrock of descriptive analytics to support the advanced stages of analytics, right? So that connection is definitely there, but inherently you are always starting with the descriptive at all the stages, and even to reach the advanced stage you would always need descriptive. It's just that if it's a pure descriptive analytics project, then you may not need these two stages. These two steps may not be needed. You would start understanding your business goal, what data you need to answer it, what kind of data preparation is needed. Do you have the data which can directly answer it? If not, how do you prepare the data? And then data exploration. And we might use graphical or non-graphical techniques to answer our descriptive analytics questions. Does it answer your question?
Yes, sir. Yes, sir. Thank you. Yes, sir. Thank you.
Right, guys. Now, as I said, we'll take a step deeper. We understand what is descriptive. We understood predictive and prescriptive. But let's say what has happened, what could happen. But if I have to answer why it happened, let's say for Amazon, they realize that they are losing a lot of revenue on laptop returns from particular type of cities, right? Now they want to understand why the return orders are very high from, let's say, for a particular type of product or a particular type of geography or demographic. So that's where diagnostic analytics comes into picture. That what happened, what will happen is fine, but examining the cause of past results. Here, as we discussed, we use very little statistical analysis. Here, we definitely use a lot of statistical analysis. Here, some amount of statistical analysis starts coming into picture, right? So this is the gap between what has happened and what could happen, which my diagnostic tries to answer. The next thing is prescriptive, which we just talked about, that my models are able to identify the best course of action on the likely outcome, optimize and improve business performance, right? Now, when we go a step advanced and we think of AI applications, that stage is called cognitive analytics. So it will be perfectly fine if you start calling this as AI also, because the applications here can learn automatically, take decisions on its own, right? So here we were identifying the best course of action. Here my machines are intelligent enough to keep taking those decisions, and they also keep evolving that decision accuracy with the period of time. So when you talk about fraud detection, so some banks have very sophisticated fraud detection system that they can automatically decline certain transactions based on the type of clicks, geography from where the clicks are coming from, amount, type of transaction, etc., etc. Or something we can all easily relate to chatbots, Alexa, Siri, Google smart bots, right? Or Tesla cars, self-driving cars these days. So this is all part of your cognitive analytics at the stage. So which is basically nothing but an extension of prescriptive. So one thing which we would want to underline here, to reach this, we typically need huge and complex set of data algorithms and powerful computing resources. So this stage is something which gets covered as part of AI deep learning courses. Because the data is so huge, the techniques which we use are very complex. The computation power is also needed, is very resource intensive. So that's why it is a combination of your cloud computing, machine learning, deep learning techniques, which we typically need to leverage here. Fair enough. Any questions, guys, on this stage? Any examples you might want to share for cognitive analytics which you see around you? I have a question for you guys. So these days when you use Facebook, it's intelligent enough that if you upload a photo, it will identify you and your friends and automatically tag it if you allow it to do so. Right? So what do you think, what form of analytics that falls into? Yes, guys, what kind of analytics that falls into?
Cognitive, I think.
Cognitive, sir.
Exactly. So Nikhil, you are right. It falls into the category. We will use neural networks, deep learning, but yeah, it falls into the cognitive because it is showing human-like intelligence. So a simple thumb rule is when my models, my solutions can start showing human-like intelligence, that falls into your cognitive analytics. The whole word cognitive means that. Okay, good. Yeah, of course, chess engines, very powerful these days. That is also part of your cognitive analytics. Great. Moving on. Now the question is, who is a data scientist? Again, we can play with a lot of definitions here, but one I absolutely love is the first one. Data scientist is someone who knows more statistics than a computer scientist and more computer science than a statistician. Now, why this is my favorite? Because practically I find it very good in almost all circumstances. Two, it also helps a question which a lot of people ask for, that I'm not a programmer. Can I be a data scientist? Or I have not studied statistics, or I studied statistics, but I don't remember anything. Can I be a data scientist? So at this stage, I'll pick up that particular question, which is commonly on everyone's mind. So guys, when we try to work in the field of data science, we need to know things from two main perspectives. One, how to apply them, the application side of it. Two, the interpretation side of it. So let's say, if I talk about myself, I do not have programming background. I studied mechanical engineering. I opened Excel worksheets first time after college. Okay. Now I can comfortably work on tools like R, Python, SQL, because when we are using Python for data science or R for data science, we are not using it as a programmer. We may, but we may not do it because that's not the sense of it. Even if Python broadly is a general programming language, but we need to know that from an extent that I can extract data, I can manipulate data, I can summarize data, I can load the data. That's it. That's why this thing comes into that more statistics than a computer scientist. I'm not a computer scientist here who needs to work on a Python from programming or development point of view. At the same time, when we use statistics, our objective at that point of time is not really to derive some theorems or prove some theorems. No, our objective is that what we are trying to answer statistically, is it satisfactorily answer? Can we establish that with certain confidence, right? So hence, when you are learning these tools like Python or SQL, you are not going to learn them as a programmer or developer. That's number one. Even when you are going to learn, let's say, techniques, statistical techniques, machine learning techniques, you are going to learn them from application and interpretation point of view, that for what kind of business problem, what kind of technique will be useful, and how do I interpret the results. That's it. So I assume a lot of you also had this question or might have thought about it at some stage. So it also helps you to answer that part. So most of the times we get this thing, it is most of the time a mental block that I'm not from programming background, so don't worry about it, guys. Of course, there is certain amount of effort and diligence is needed, but it is not about what you have done in past. It is more about how much effort and focus you are ready to put at this stage. Now, the another definition is also important because yes, it talks about the two things we have touched upon, but there's another thing to it. As a data science professional, you also ought to explain, let's say, technical concepts or data concepts to non-technical, to a non-data guy, right? So you need to have that, or you need to develop that skill that you have got some numbers, some insights. How do you explain it easily to someone who does not understand data or statistics at all? So storytelling and bringing a little bit artistic approach to it to make, let's say, nice dashboards which others can understand or it makes it easier for people to process complex information in faster manner is going to be important. So that's why some of you would be starting with, let's say, data visualization analytics. Some of you might have already done it, right? But as part of a complete data science journey, all this is important, that you understand data analytics, data visualization, machine learning, and modeling. So, good question. See, it helps if you remember these things like linear algebra, multivariable calculus, etc. But if you do not remember that and all that, we do cover some basic concepts related to this, because again, you do not need to learn this to do these calculations by pen, or you, let's say, do calculus or integrate an area. You just need to understand, if tomorrow we are talking about finding a minima, right, or maxima, what is minima or what is maxima? Now, when I say minima, maxima, it may ring a bell because at some point of time we have studied these things in school, right? So that's the idea. You need to understand these things, that at least conceptually, notionally, intuitively, you can understand that what is the machine learning model doing at the back end. Of course, we are not expecting you to write the algorithm for that machine learning model. We are just expecting you to use that machine learning model and understand what it is doing so that you can also interpret. Right? So we have small pre-learnings before each of these sections as part of the course, which you are required to go through, so that that understanding could be there. So if you are, let's say, someone who like maths, wants to understand, you can go into as much as deeper you want. But if you are someone, let's say you do not like maths, but it is now compulsion for you to go through these things, then the idea would be just to understand at a conceptual level, not at, let's say, derivation level or by hand calculation or something like that, and interpretation level. That's it. That will do the job for you. Okay. All right. So, so in short, if we see what does a data scientist do, what are the responsibilities, you will also be able to map this with what all we talked about: descriptive, predictive, and prescriptive analytics. In terms of process, also we talked about obtaining data, preparing the data, exploring the data, building models, interpreting results. So these are the steps which you will be part of your day in, day out work. These will be the kind of analytics or the problems you will be dealing with. They may have combination of all descriptive, predictive, prescriptive, or one of these. But mostly the business problems will have combination of these, or at least first two, descriptive and predictive. Right. And of course, there are many things or techniques which you will be learning about as part of the course, like hypothesis testing, data visualization, we just talked about, machine learning, understanding the concept of parallel or cloud computing, some basic introduction to deep learning. Depending on what learning track you have opted, you may or may not go with deep learning, right? Python coding, which is needed to use Python for data science or data analytics. Database querying like SQL. Okay. Now, next important thing is about the job roles and how data science is a multidisciplinary skill. But to understand this in detail and successfully, we need to spend some time in looking at the data science from tech point of view or from organization point of view. Okay. So what I have on my screen right now if you're looking at it for the very first time, this will look very complex, overwhelming. We will divide this into different pieces. But what is this essentially? This is a data science architect, data science architecture from enterprise point of view. Because when we talk about data science, data analytics, we think about the analysis, visualization, dashboards, etc. But at enterprise level, there are a lot of things which goes behind it. You may not have to deal with all of these things directly, but it's important that we understand these things, right? So first let's understand where everything starts from, that is data. So we live in a very interesting world. Right now, there are around 7-8 billion humans on this planet, but there are over 50 billion devices on this planet which generate data, right? So if you talk about smartwatches, if you talk about the video cameras, streams, the cars are intelligent these days, even our electrical equipments, power generation, right? Your ERP, CRM system, CRM stands for customer relationship management. When I talk about that coffee shop example, why that coffee shop was recording that who are you and what are you buying? Because they are trying to maintain CRM for future business activities. Similarly, if you do not know, there is something called ERP, Enterprise Resource Planning, which large companies use to plan different business functions and activities. So in short, no matter what we do, whether we do shopping or we go buy car somewhere and all that, we are invariably generating or being part of a lot of data generation. Now, this data comes up in various forms. It could come as speech data, text data, social media data. It could come as Excel data, CSV files, right? The data generated through data storage application apps we use, right, from your mobile, tablets, etc., etc. Gaming and of course social media is all part of it. Now, some of this data is structured. For people who do not understand structured and unstructured data, not a problem. You will, of course, start dealing with both of these things at later stage. But for now, let's say the data which I can simply store as numbers and text in tabular form, it could be an Excel file, SQL table, etc., is your structured data. A simple example could be credit card statement. What did I buy at what date of what value? I can store that data as Excel file, right? That is your structured data. But when we are, let's say, chatting on any social media platform, or let's say updating our tweets or Facebook, we are using a lot of text data. Or when we are talking to any customer care, where they're also recording all these conversations, we are recording this as both the things, the text data or speech data, that is unstructured data, because you cannot store this data as tabular data. This data is in a different form. You can't define this into numbers and all that. Eventually, to do analytics, we have to do it, but that is still unstructured data when it is generated. So this is the whole array of things which we see at the initial stage. Now, organizations need to ingest this data. They ingest this data, they store this data on the cloud storage, where many kind of activities are done. Data integration is done, data cleaning is done, right? Deduplication. If let's say for same customer, they are duplicate data for same transaction, that is going to happen. For same customer, we have data from Twitter, Facebook, and also ATM. Blending of that data may happen. So a lot of things have to happen, which is basically part of something else called data engineering. So the whole thing, from ingesting the data doing certain activities, loading that data, storing that data, so that that data can be consumed for further business purpose. That further business purpose in our case is analytics and data science. But this whole set of activities is called data engineering, right? So when I say data engineering, do you guys understand that part now? Because this is a term which you may have come across in past, but you will come across this term a lot often as you start your journey in data science. But in short, the activities which we do to extract, transform, and load the data, which is also called in short form ETL, that's mainly part of your data engineering. So the whole process of capturing the data from different sources, storing it, processing it so that it can be consumed for other business activities, that is your data engineering. Is this part clear, guys?
Yes. Yes.
Okay,
Yes, sir.
good. Okay,
Sumit, one question.
yes.
So does this data engineering is a part of a data science, or it's a outside world from where after the data engineering the actual data science work starts?
Good question. I have to cover this anyway, but let me answer this. If I talk about the data science as a domain, it is part of that domain. So data engineering is sub part of your data science domain, because we need data science to successfully execute or accomplish data science projects. If I talk about job role, then the job role of data engineer and data science are separate job roles with some overlap, which I will be talking about. But yes, data engineering is very well considered as part of your data science. Sorry, 1 second. I closed this. Yeah. Right. Okay. Now, the next thing is, as you see, the analytics or data science layer, where once I have the data, which is clean, can be used, right? And by the way, I must mention the data cleaning, which we talked about as part of data science process, still holds, because here we might have to again do data cleaning and data processing, because what we did here was the very essential one. For example, for a customer, whatever they are buying on their credit card is being recorded, right? So this process is taking care of that information can be recorded for one customer. N number of transactions are there. Okay, but when I'm doing analytics at that time, I need that for one customer, I need average and total spend of that month. I do not need every single transaction. So I may still do some of the things which have been done, but here we do things at a very elementary and essential way. Here we do things which are required for our analytics purpose, specific business purpose. So in this case, the whole process which we talked about still comes into picture. If you see the business understanding, problem identification, diagnostics, data understanding, data analysis, visualization, generate insights. So a lot of overlap or similarities which you see, which we talked about the past of our data science process: data preparation, model building, evaluation, deployment, which at that point of time I use the word automation. So we may do descriptive analytics, after this predictive analytics, prescriptive analytics. We may just do descriptive and generate dashboards, etc. Or we may go up to and creating analytics apps, or let's say even mobile apps which are data science powered, right? So from enterprise point, being a data science professional, your sphere of concern might be this much, but it's important to understand that from an organization or enterprise level, your journey starts from here, right? And anyone who is working or operating in this sphere should have a view or should understand what all goes on there. You may not do all this hands-on, but you are likely to understand what all will be needed or what all goes there. Fair enough? Vijay, good question. I'll answer this in detail, but for short now, no. At least not for 5-10 years. I have been a part of this for 15 years now, and every year. And of course, at some point of time, I also used to worry about it, especially also when I started own firm in the same domain. But the demand is ever increasing, and there is a reason for it. Still, you see a lot of things are not using data or data science, but at the same time, you see a lot of businesses, industries, processes are leveraging data science. So the scope which is there is still immense, and the kind of businesses or the businesses which are still not using there are lot many. So trust me, all type of businesses, clients we deal with, they are still struggling to fire good talent. So at least for next 5 years, 10 years, definitely no. Okay, going to the next part. Yes, Panti. So next part actually takes care of that question also. Different type of analytics job roles. Sorry guys, before I move to this one, final time, any questions on this? Anything which is not clear about this? Okay. Swaroop, I will take up this question right here on this slide. Let's move here first, okay? So guys, what is something we have noticed in previous slide, that at an organization or company level, to leverage data science, there are a lot of activities and steps in the value chain. So we often hear the term data science, data scientist, but when we think about or get to a stage where we finally have to build a career in this domain, we need to also understand the various different type of job roles rather than using the umbrella term, right? So the kind of architecture which we saw in the previous slide, someone who is responsible in developing that pipeline, that solution, right, which can allow companies to capture the data, integrate data, organize, centralize, and maintain the data. So that job role is called data architect. So this is another job role. Once you become part of data science domain, you will very often hear about, if you have not already heard about. Right? So first thing is data architect. So what is the key responsibility? Whatever we saw here on the previous slide, this guy is responsible for designing all this so that data can be captured, stored, organized, and centrally available for next set of applications. Now, the person who does all this, what? Extract, store, transform, load the data for next set of applications, that guy is called data engineer. So the one who designed that system is data architect. The one who execute these things and does it day in, day out is data engineer. So is this difference clear between these two guys? Okay. Now, what happens is in some companies, it is possible that same person might be playing both the roles, especially if it's, let's say, a startup or it's a service company, consulting company, then the same person or the same teams are responsible for performing both the responsibilities. However, if you talk about, let's say, large companies, let's say like Amazon, HSBC, Standard Chartered, right? Basically, companies which are very well established or have been evolved on the data science side. There you would have different teams or different persons playing these kind of roles and responsibilities. Fair enough. The next thing is the way we have fungibility between these two roles, right? So the fungibility between these two roles is of less importance to us, but we should understand that because we are not really targeting this job role. This is a job role which is purely IT driven in nature. So that's not our concern when we are looking at a career track or the learning tracks we are opting for here. However, the other side of the spectrum, which is data science, that data scientist and data analyst, this is very much important to us. So first, let me pick up this one from the spectrum. So this question came up, that difference between data analytics or data analyst or data scientist, that is something which is going to come up now between these two blocks. So someone who is responsible for data collection, data munging, which is basically your data manipulation, data visualization, analytics, applying statistical analysis, and let's say presentation or dashboards. This person is basically your data analyst, right? Now, what happens is when you move from data analyst to data scientist, all this is going to be true, right? However, dealing with machine learning models, dealing with structured, unstructured data becomes very important. So data scientist is basically someone who, along with all these things, can also handle unstructured data, leverage machine learning, text mining, NLP, etc. for various kind of data science or business solutions. Now, what happens is when you're starting your career, it is possible your designation might be data analyst. 70-80% of the times you are doing or taking care of these responsibilities, and 20-30% you are taking care of these responsibilities, right? It's also possible that you are dedicatedly working on this area, but after 1, 2, 3 years of experience, you then start gradually moving to this role. But very important thing to remember here is don't go by the designations, because we have seen that companies will give the designation of data scientist, but that person is 100% doing or taking care of these responsibilities. Or we have also seen other way around, that designation is data analyst, but you are taking care of these responsibilities most of the times, right? So two things very important to understand. At the beginning of your career, it's possible your main responsibilities may be leaning towards data analytics with some data science, and gradually move to data scientist. And whenever you are applying, going through job roles, etc., do go through the job description and not just the designation, because sometimes the designation will say something, but the role will be something else, right? I'll share my example. So in first 2-3 years of my career, I mostly worked on this side. in fact, at that time, there was no designation called data scientist. It came much later when I was into, let's say, 5th, 6th year of my career. But I was more or less in every project taking care of these kind of responsibilities, right? And then there have been also areas of projects where I played the role of all three, data engineering also. So this is another thing which I wanted to talk about, that there always will be fungibility between the different roles. And even you are working on the data science or data analyst side, it is possible that there will be some responsibilities on your plate from the data engineering side. Let's say you are not supposed to design or do complex things, but at least extract the data from your central databases or manipulate that data and then use it for analytics rather than an external data engineering team doing it for us. So depending on the learning track you opt for, you would be either focusing on this with some amount of this, or you would be focusing very well extensively on this. Or if you're opting for, let's say, the popular learning track of integrated program we have, you are targeting all these three. The thing is, when you're beginning your career or building your career, the more job role responsibilities you can target, it increases your job prospects. And another thing which I must mention, lot of people, just because the term is fancy, sounds glamorous, tend to focus a lot on the data scientist, but there is a big, huge skill gap on the data engineering side. And trust me, at the beginning stage when you're learning some additional things related to data engineering is not difficult at all. So this is something which you must pay attention to, especially when it is likely that as a beginner, you may start as data analyst with some responsibilities related to data engineering and some responsibilities related to data scientist. And of course, there is always a possibility you may directly get the designation of data scientist. So I hope this is something which is helpful to understand and might have already answered many questions on your mind. For example, the recent question which we have seen is on people coming from BCom background, non-technical background, right? So we have students who are actually, forget about BCom, etc., because BCom is still involves a little bit of from BA background also, and they have succeeded in making good career in data analytics, and that too when the term or the field was not super hot like it is today. So even in 2015, 16, we had candidates from non-technical background who very successfully made the transition. Now, only thing is, if you are, let's say, from data, you are from engineering background, computer science background, the possibility that you may directly get this designation is little higher. But if you are from non-technical background, you very well start your career from this side, right? And with learning and experience, you move to this side. So this is something we have seen, let's say, every day, day in, day out. If you are from technical background, let's say from tier 1 college and all that, the chances of getting a designation and job role directly a data scientist is higher. However, huge chunk of our students successfully start their career in data science. Maybe the initial designation might be this, and then they successfully migrate to data scientist roles, right? The other thing, other question which is pending on chat, I'll touch upon it. But before that, guys, tell me if you have any questions. Any questions just related to what I have discussed? Sona ma'am, I'll come to that. yeah, I will be after this. I will be moving to the section of popular courses and the certifications we have. Right?
Hello.
Yes,
Yeah, is my voice audible?
it's audible. Yes.
Yeah. So good evening, sir. My name is Nikhil Ranjan,
Yeah, I
and yeah, so I've been, in this space, and I've been trying to learn this technology for
Mhm.
like around 1.5 years,
Mhm.
and I started off by learning Excel, and
Mhm.
after finishing my course on Excel, I found that Excel is a really good tool,
Mhm.
wherein we can find the regression, R square, those things we can find out. But it's
Mhm.
not that handy to hold that much amount of data.
Right.
So I came across tools like Tableau, Power BI, and other tools are also there. So my
Correct.
question is, like, today I was going through a material, on machine learning, okay, and wherein I found that we have to explicitly code, certain models. Like if it
Mhm.
is anything, we have to make certain, visualization in Python. So in
Mhm.
order to visualize the thing in Matplotlib in Python, we have to code it accordingly.
Mhm.
And do we have to, be proficient in that? I'm not getting that motivation, like for
Okay.
how long we will be doing it and all that.
Okay.
So it's
Okay.
my concern is regarding, because I'm okay with SQL thing, because SQL part is not that hard for me, but Python is a little critical, because it has a lot of packages, it has a lot of
Correct.
libraries and those things. So my concern is regarding this thing, coding in
Correct.
Python.
Okay. Good question. So let me answer very practically, right? I also mentioned in the beginning of my session that I am also not from programming background. Okay. So
Yes,
there are two
yes.
ways to it. So I don't intend to discourage anyone, right? But I am basically sharing here very, very pragmatic scenarios which we have seen with our students. Okay. So we come across candidates, they say that even when they are let's say sticking to the role of data analyst, business analyst, in comparison to what they were doing earlier, this is still lucrative. And in this, they are mostly working on Excel, SQL, okay, maybe Tableau or Power BI, any of the this visualization tools, and they do not intend to move beyond. And maybe for basic data analytics or something, they are either using R or Python, and they are satisfied and happy, and they don't want to intend to go beyond this. Okay, and they stick to this role, because within this role then you can take up a role of TL manager, let's say client account management, etc., right? And of course we have a lot of students who say that, okay, we have come this far now to really excel in the field of data science, or even if I have to go to AI, now I have to go a step further in Python, right? There, when you say a lot of packages do come into picture, yes, a lot of packages will come into picture. We'll have to do machine learning, deep learning, etc., right? And the challenge which they are little bit scared of, or let's say apprehensive about, is exactly what you have mentioned, is programming. So one thing which I mentioned is you will have to do a little bit more than what you have done here to go to this site. However, think of this way, your top 5 packages, okay, will do 90%, or let's say 95% of the work. So even if you, let's say, see the number of packages which comes in your Python distribution systems, they will be, I don't exactly remember, last time I opened, there were around 1500 pre-installed packages, but your top 5 packages, NumPy, Pandas, okay, Matplot, Seaborn, and scikit-learn, will do 95% of the job. So you are not really going to worry about the remaining hundreds of packages which are only needed 5% of the times. Point number one. Now what happens is, when you are dealing with this when you're learning, yes, you are overwhelmed, but when you're dealing with this while working on a case study on job, when you are using this day in, day out, you also get that sense that what is going to be used most of the time, those things you recall by heart, and you can write that, let's say, line of code even while sleeping once you are 2 years, 3 years working in this domain. Okay. Now the second stage is, we all, when I say we all, people like me who are not from programming background, we maintain a repository of codes. So let's say I need a data visualization, and for that I need a package like Matplotlib. Okay, I just need to know that yes, this can be achieved in Matplotlib. I have that code somewhere. I just maintain a repository. I will pull out that code and modify based on my current data set and variables. I don't remember those codes by heart. I don't expect my students to remember those codes by heart, but all I expect is that they know what has to be used at what situation. Those repositories, even if you're not maintaining on your system, can be available online, offline, right? You just know how to modify it. So for these 5% of challenges, it is not, I don't think so it's wise to let go the 95% of the opportunity. You are getting my point. So yes, there is going to be a little learning curve, a threshold you will have to clear. That's what your mentors, your structured learning is supposed to do. But that intent, that effort, the time has to come from you. But most of the time, this will suffice more often than not. And do not worry about these 5% of cases. You will have to go back to your code repositories. And trust me, these libraries do keep changing. The tools keep changing. When I started working, SPSS used to be the most popular tool. Then SAS came along the way. Then R Hadoop combination came up. Then for last now 4 or 5 years, it's Python. Tomorrow it could be something else. So all we are trying to help you is develop a thought process and approach. Your tools may change. Don't worry about that.
So the recent thing, I was going through a material on data engineering, and I found that the automation has taken a lot of work. My friends have also been given projects on automation, and it's difficult for them because the knowledge training is not properly given in the companies. Once people are hired based on certain job description, they hire people, even if the interview is not that well, even if the guy is not that well.
No, we are now getting into a different area here. So I'll not go there, Nikhil. So yes, automation is picking up very well. And it is possible that you got hired for something, right?
And
But
the
your
projects
organization now wants you to put into something else. Yes, these are some of the
projects.
challenges that we always guide our students how to go about it. That's why I said in the beginning also, don't go by the designation, go by the job description. Talk to the TL of the team you are going to join, manager of the team, try to get some feedback from the people. So all those things we guide our students. But let's first reach that situation. We are a little ahead in the behind in the curve to worry about that. Right?
Thank you, sir.
Yeah. Okay. Now, guys, Tableau and Power BI competing in very similar tools. That's why we give option to learn both the sides of it. So Bunty, I think I answered your question that even if you're from a different background, non-technical background, you may start from basic data analyst role right now and gradually make your move. And we have a lot of such students along the way. Now, there is one question from Swarupa, so which is pending. I will be taking up your question. Give me little bit time, because one thing I ought to discuss before taking up that question is reiterating this thing. We have already talked about it, that data science is a multidisciplinary skill, right? So you could have a spike on the technology side where the roles like data engineering, data architect, ML ops will come into picture. You could be someone who is good with the analytics skills, where you may stick to the roles which are, let's say, more analytics heavy, let's say data mining and visualization, statistical and ML modeling, right? Or in many cases, we have people who come with, let's say, 5, 10, 15 years of experience in business. They were, let's say, part of marketing and sales. They were part of operations planning and all that. Now, for these people, the objective would be not directly, let's say you have done this thing, you have been on the business side for 10 years. Now you can't suddenly jump and become a ML or statistician model. So that is where the non-alignment of expectations come. That's why we basically take a good amount of time to help you to understand this. That after 10 years of experience, do not try to get into an IC role, individual contributing role, and say, I want to be a data scientist. Yes, there are cases people succeed in that manner also, but there are very few cases. You have to understand that, as we discussed in the initial slides, that not everyone has to be a data scientist. You could be a business leader who is data science or analytics literate. You understand how for improving sales you can use analytics, or you could be someone who understands that to improve the production planning or demand, or let's say supply chain management, how can I use data science? So a lot of candidates we get are from this domain who have been onto the business side, but now learning data science to play these kind of roles, right? So identify where do you fall into the spectrum, and do not jump the bandwagon just expecting that everyone has to be data scientist. No. Unfortunately, not all tech companies do an honest or right job here of guiding that after certain years of experience, what is a right approach for you to take. No one is saying that you can't be a data science professional, but you may not be equipped or best suited to be a data scientist who is working at the back end and working on the Python programming and SQL, etc., day in, day out. So hence it's important. And let's say you are coming from technology side for last 10 years, you have been working on that development side, technology side, right? It would be a good option that first you pick up a role focused on data engineering. And even if you want to be a data scientist, it could be a gradual move for you rather than directly trying to be data scientist and struggling along the way. So hence this part is very, very important, right? This is also related to your question, Swarupa. So now what is happening is, given the skill gap at different roles, at different positions, companies do need people who understand data science. They want to leverage data science, right? So they are open to people who have added this as additional upskilling thing, not because it's a new field. It's not possible. Let's say they want a leader to manage their clients, but start nurturing the analytics business from the client. But it's not possible to get someone with 10 years of experience who can do client management and also understand analytics. So in a lot of these cases, the companies are open for candidates who have, let's say, done some professional certifications, right? And can play that role with the past domain knowledge plus the analytic skills which they have recently acquired. This is one of the reasons a lot of initiatives from companies, from government, you would see in this direction. Let me share an example. if I talk about when we started in 2011-12, the kind of role we people like us were playing was very limited, because we were either mostly looked upon someone who would be used for corporate trainings, right? But the upskilling side was never seen to be another line of education or another source of talent pool. However, what is happening over last 2-3 years, and especially the pandemic has really accelerated this. We get a lot of calls every day on regular basis from recruiters, because now they very well understand that how technologies, techniques, and the job markets change. The upskilling, learning, unlearning, again learning is the only way. The formal education, the formal method of, let's say, acquiring a degree and working in that domain for 30 years, that does not work anyway. In fact, with this, I'll jump to this part, because there is one course which is basically is mandated by Government of India. So the point which I'm trying to make here is, whether it is government, whether it is private organizations, large or small startups, now everyone very well realizes that the new age job roles would need a skill-based education, where we will have to go with the model of career or job mapped learnings and skilling. So for example, we have one program, Data Science 360. I'm jumping one program right now. I will come back to that. That is basically our main flagship program. But why I'm talking about Data Science 360 at this point of time? Because last year in December, this program was validated by Government of India, and we now deliver this program as part of collaboration with Nasscom. So between Ministry of Electronics and Information and Nasscom, there is an initiative called Future Skills. So this whole program of about 6 to 7 months is co-branded along with Nasscom, right? And the Government of India is providing support to this program to an extent that post completion of this program, you also even get 8,000 rupees direct scholarship, direct feedback from the Government of India. Now you can imagine, if government realizes this, how private enterprises and entities are looking at it. So no matter at what stage you are of the career, data science definitely has a role to play. The key thing to remember is, based on your experience, if any, or your education, what role do you pick? How do you approach that domain? So that's the mistake which most people do, and that's where they then are at loss that what is happening, or maybe they are making wrong decision. So if you are making an informed decision based on your own strengths and experience, then trust me, there is a lot of roles and opportunities this domain has, whether you are from technical, non-technical background, or you are a fresher, or you are an experienced candidate, right? So I think in the same regard, I have one question here. So see, in bioscience also, there are two ways to think about it. If you are interested to pursue your career in the same sphere, let's say biotech, bioscience, yes, you would find data science opportunities. But even if you are not, let's say, someone who is willing to continue in the same field, let's say you graduated in that or postgraduate in that, but you are not finding it interesting enough, and you do not want to continue that, that's fine. That's the whole point I'm making, that about the skill-based education. So you studied science field reflects your aptitude, right? But it is nowhere mandatory that you have to stick to that. If you want to stick out of interest, yes, data science has a lot of role to play. So all kind of pharma companies, from Novartis to even your Bharat Biotech, they have data scientists, or they use data science for various functions, from your product development, from your R&D, and even from your sales and marketing point of view. Sorry, I just realized there is one pending question from Lena also. Database, diploma, SQL, junior software engineering credentials. Yeah, Lena, you already made a small step. Let's say moving from your core engineering, mechanical engineering, you're already working on the IT side, right?
Yes,
And
sir.
especially anyone who has exposure on the database, data management, right? That transition is very effectively possible. Only thing is, I
Yes.
said, it might be more worthwhile you consider this role also, and rather than just this role, you may want to begin with this.
Okay, sir.
Yeah. In fact, we are recently hiring for one company where they want to hire 1,000 data engineer professionals, and they have given us a mandate of hiring 30 for them. We will be selecting few students from our current base, or inviting new applications of training candidates for that role also.
Okay.
Okay, so guys, this is something many people are waiting for. I'll jump to this part. I'll spend time on 3 important courses, which are the most popular one. So one is the most extensive course which we have, that is Integrated Program in Data Science. So in this program, you basically start from the very basics, like building blocks of analytics, where you learn some fundamental concepts. Let's say you are from non-programming, non-technical background. So all those fundamental concepts are very well taken care of at this stage, so that it makes easier for you to learn tools, even when you are starting from the very basic tools, let's say Excel, Tableau, SQL, right? VBA is also mentioned here, but that is optional. So broadly, this module is your data visualization and analytics. The next module, as part of this course, you move to data science and machine learning using Python. So in this module, you will be learning how do we use Python. I am underlining this point. For data science, we are not learning Python here as a programmer. Okay. Then we learn statistical modeling, machine learning modeling, text mining, and NLP, which is very important part of any data science job role these days, and introduction to AI and cloud computing. So in this model, we are not going in depth, but yes, what is essential or fundamentals you need to handle machine learning concepts. Then this is later on, the other module which we have is on the data engineering, CBD, Certified Big Data Engineering, where you would learn about the Hadoop ecosystem and Spark, NoSQL, MongoDB, and cloud computing. So this is the module which is basically essentially helping you to play the role, which I said at some point of time I had to play on a one extensive project. This one. So it basically focusing on this spectrum, data engineering side. Then we move to AI and cloud computing, because these days, even to do AI and deep learning, you need to have some basics of data engineering place, cloud computing understanding, and we will then focus on deep learning techniques using TensorFlow, your applications, which I just asked, let's say computer vision, the image identification. We used an example, right? How Facebook identifies you and your friends, even if you upload a picture, right? Or your chatbot, smart chatbot. So all this is part of the AI deep learning module. The next one is ML ops and deployment. Now you may recall when we talked about data science process, right? We said that deployment or automation is needed, that we have built the models, machine learning or AI models, Now, how do we put them into practice? How do we put into action that businesses and organizations can be used? So your ML ops and deployment takes care of that part. So this is something which most data science trainings is misses on. It's a small module, but it's a very important module. Sometimes that makes a difference whether you get hired or not. Even if we started focusing on this side about 1 year back, based on the feedback from the recruiters and the students. So this is going to be extremely important in current job scenario if we talk about. So if you are looking for job in data science, you are learning machine learning, text mining, etc., AI. Without this, that's a half job done. Okay. Now the next set is industrial and functional sessions. Here you will get an understanding about key business domains, business problems, and how whatever we have learned can be deployed or used to solve different type of problems. However, it's important to remember you only graduate to this module once you have done the previous modules. And for all the modules, even which I'm going to talk about in the next slide, R for data science is an optional module where you will be learning R programming, statistical analysis with R, regression and machine learning with R. This cost about 20K. However, as part of these combo courses, you can just avail this in additional 4,000 rupees. So that's a great add-on, and sometimes it's really a lifesaver, because in a given time span, you can focus on certain things. However, it is possible that you may come across a job opening where they say, it's good you know Python, but hey, we work on R. So good thing is, once you have learned all this much, learning this becomes a cakewalk. So we want that provision to be there at a very nominal cost for our students, that they can switch and learn it. It's basically, in short, enhancing your job prospects. So guys, this course takes about 1 year to complete. You get 1.5 years to complete, but the depth and the breadth of this course is more than, let's say, the expensive PG programs you will find in market. So if you, let's say, are not really looking for an additional degree, but you are looking for some extensive learning in this domain with end-to-end employability and all the skills you needed, this is definitely the program you should be going for. Any questions you have on these modules, on these assignments, guys? Okay. The next, yeah.
I just enter now to the lecture, because as the difference in the time between India and Saudi Arabia, if it is possible to send the lecture after you finish, it will be good.
Sure.
Revise what you say.
Sure.
Because I will start tomorrow, inshallah.
That's okay. So anyway, we will be sharing the recording also of the class if you have missed this, right? And at the later stage, me and my team would be very happy to connect with you one-to-one also for your questions.
Okay, I am already enrolled in program in Bangalore, which will be weekdays, start 21 March from tomorrow.
Yeah.
I don't know, it will you will send the lecture as on my account, which I registered, or on my mail, or which tool?
So it will be on your account also. So let me just spend another 5-10 minutes on explaining about this courses. My colleagues will be taking over this session to answer with all the questions let's say, how do you access the course you have already enrolled for, how it will flow from tomorrow onward. So you will have all that assistance. So my colleagues are also in the session and they will be helping with those things.
Okay, thank you.
Okay, sure. Right. Okay, so guys, what we were saying that this is the most extensive program you will find for this price and the duration. The next program, which is also very popular, we have is Data Science 360. The main difference between integrated and Data Science 360 is going to be these two modules, the in-depth data engineering and the AI and deep learning. So these two modules are not part of your Data Science 360 course because these two modules are advanced modules. We only offer as part of your integrated program. So here, you cover all the things which we talked about in terms of your data visualization analytics, your Python for data science, predictive modeling and machine learning, right? Text mining, introduction to AI and cloud computing, ML ops and model deployment, and industrial function session. So the main difference between integrated and this one will be the big CBD, the big data engineering, and AI and deep learning course modules. What I explained about R for data science, the same thing is applicable here. So even in this program also at a nominal cost of 4,000 rupees, you can avail data science using R, the full course in the e-learning format. Any questions, clarifications, guys, for Data Science 360 or integrated program?
How long the
Okay.
Data Science 360's time frame is?
Data Science 360 takes about 7 months to complete, 6 to 7 months.
When it will, if we started from tomorrow on weekdays program,
Weekday,
when
the
will we
duration
finish?
will be smaller. The weekday duration would be smaller.
Smaller, how
I
much?
think
How many?
Yes, exactly. Because the number of sessions and classes per week, they are higher in this case.
There's 4 days on the week. When it will finish?
Yes.
6 months or maybe 4?
Sorry, I missed some part of your question. Can you repeat that?
So what's the duration of the course for a weekday batch?
So for weekday, it is about 4 to 5 months. So 4 months, but effectively covering your doubts, case studies, and all that, it takes up to 5 months.
Okay, thank you.
Sir, do you also have the weekend batch for the working people?
Yes, yes. So both the programs we talked about are available. Sorry guys, I'm putting everyone on mute. There is some background noise. So answering the question, yes, the program is also available over the weekends where the classes will be on Saturday and Sunday for 3 hours each.
And sir, it will be offline classes at your center in Gurgaon?
Yes. So we have offline and online classes available. So offline are available in Noida, Gurgaon, and Bangalore.
Okay.
Sir, Gurgaon, can you please tell the address, which sector?
So sure. So just ping directly on the chat, or my team member will ping the address. It's near IFCO metro station, just adjacent to the IFCO metro. Correct. Right. So guys, just hold on for all these questions. I have my colleagues available. They will be taking up these questions once I am done explaining some of these important piece of information. They will be taking over and explaining this.
Hello.
Yes.
Yeah, so like from the starting of the meeting, we have been, discussing about this word data. And you also said that whenever you are doing some transaction, there is a lot of data being generated and it will creep on and on and on.
Correct.
Okay. So a lot of companies, you mean to say that a lot of companies are trying to get that data and then try to get insight from the data, make some meaningful decisions.
Right.
And you also mean to say that a lot of companies are also selling the data and selling it to some other vendors, selling it to some other parties, so that other companies can also get benefited through this data.
Correct. There are basically businesses which primarily is into selling the data, but that is if it's a legal entity and proper entity, that is done in a permitted manner.
Yeah. So based on this, there is a lot. There is a whole, you can say, a community of an industry where this whole data, work is going on. An ecosystem where this whole data work is going on.
Right.
Like that, because as the number of the data users are increasing, the data engineering team has to manage that much amount of data.
Exactly.
Because they are the first people who will be encountering that much amount of structured, unstructured, managing
Exactly.
it.
That's what we mentioned here when we talked about this at enterprise level. This is extremely important, and that's what I said, that most people they undermine the role of data engineers or the amount of demand we have for data engineers in the
Data
current
warehouse, the data lake,
Correct.
and the
Correct.
Hadoop. So, sir, in the program which you were just, can you come to that slide? The integrated
this is the
program. Sir,
program we
here
are
the database
covering.
here where do we get the big data? So, number 4.
Yes.
Number 4 what about SQL, sir?
So
The
SQL,
RDBMS?
yeah. So SQL we have already covered in the initial modules.
But it's not mentioned here.
Here in
Achha,
second.
SQL. Okay. So RDBMS and then no SQL is there.
Correct. So when you are reaching here, basic SQL is kind of prerequisite, which is already taken care of.
Yeah. Okay. And sir, the integration part of these things, the integration of the SQL with Tableau, SQL with these things.
It is covered. So for example, Python and SQL is important, right? And even when you are learning Tableau, it is taught that Tableau can be connected to multiple data sources. So all that is discussed and shown. So you may not see everything in this condensed form.
No. My question is not regarding, I'm not able to see. My question is just that when can we expect that transition by ourselves? Like when are we going to learn it, in the program? Like after finishing the second module, we'll be proficient.
So some of these things would be yes after the second module, when it is just something basically that when you're working on SQL and you have to when you're working on Tableau and you have to get data from SQL, or let's say any other equivalent Redshift, this kind of system, right? So that is going to be discussed here. But a lot of these things are then, let's say we have taught you up to 80%, remaining 20% somewhere we are expecting you to do it. But even that somewhere will happen along the way, because as you are working on various type of case studies and projects, a lot of these practical challenges and the solutions will come along the way.
And sir, about the academic team, like when are we going to, introduce us with the academic team? Who all are there, and what do they really?
So depending on batch to batch, let's say which batch you're going to join, it is shared well in advance who is going to be the faculty. But by and large, for all the programs, there is certain minimum criteria we maintain for our faculty members. Okay. So what is the program which we follow is that when you come to, let's say, machine learning or these advanced applications, anyone who has worked in this domain at least for 5-7 years, not let's say overall 5-7 years of experience, but at least 5-7 years of experience in that particular domain, let's say who's teaching you machine learning, should have done that practically in industry. So that's the approach which is taken. So right now, if I share faculty with you, it's going to be very generic. That's where my counseling team can guide you that which batch, which location you are considering, and accordingly, who will be the faculty for that.
Okay. Sir, one more question is regarding NLP. Like it's mentioned in the third module that NLP will be also taught. Is this like natural language processing related to voice of objects, voice of people?
No,
Are we going to something?
No. This is natural language natural language processing based on when we deal with, let's say, text data, unstructured text data and all that.
Okay.
How do we use it in that case for
different dialects.
Correct.
And different. Okay. So it's kind of text mining and those things.
Yes.
So, like, sir, I had a project in my mind. If you can just throw some light on that. Now, suppose a dog is having a sound. Okay. Now, if I want to
you allow me, so I would love to address this question. However, in the larger group's interest, let me first finish about the rest of the program and the certifications. Okay. I'll come to it. And in fact, I believe you must be in touch with any of my team members. They can help you to schedule a call with me.
Sure.
Right. Okay. So, guys, a third program, which generally I do not believe you should have many reasons to take up this model. I'll tell you why I'm saying so, is Business Analytics 360. So this is everything what we are covering in Data Science 360 minus your machine learning and ML ops and AI cloud computing. So in this program, Data Science 360, Business Analytics 360, we will not be covering, sorry, one second. This part and this part, right? So if you see the Business Analytics 360 program, it will be easier to understand that. What are we covering is, again, your data visualization analytics, Excel, Tableau, SQL, Python for data science, and we are going up to statistical analysis and regression modeling. Some basic info on machine learning, but we are not covering the machine learning part. However, in this case also, you have a facility if you want to opt for data science with R at again a nominal cost of 4,000, that is available. However, the things related to machine learning, text mining, NLP, introduction to AI cloud computing, and ML ops, that is not being covered in Business Analytics 360. Now, I made a very strong statement that I do not see many reasons why you should go for Business Analytics 360, because for any program which is, let's say, Data Science 360 or Data Science 360 onward. So for the Data Science 360 module, as I explained, the course is approved by Nasscom. It is aligned to the industry standards. So there are basically 9 job standards approved by Government of India. This is called NOSIS. Our program is aligned to, right? And as I said, our program is also backed by Government of India to an extent that you get a scholarship of 8,000 rupees directly deposited in your bank account by Government of India. So if the cost difference between Data Science 360 and Business Analytics 360 is roughly 10,000 rupees, but the advantages in terms of curriculum, the kind of certification you are getting with it, and of course with the scholarship advantage, there is not many reasons people go for this. So that's the reason I mentioned it. So For end-to-end role, you must be considering this program, integrated program for data science, or at least for data science 360. If you have enrolled, or let's say are considering business analytics 360, give it a thought again, at least upgrading to data science 360, given all these benefits we have from the government of India. So this is one thing I wanted to emphasize upon. But any questions finally on these 3 learning tracks, any module or syllabus from this?
If someone newly stepping into this sector, can they start with business analytics 360 and later opt for data science 360? Or is it
no, so basically what happens is when you enroll for data science 360, we have to share that data with government of India within first 15 days. So every fortnightly that data is shared with them. So let's say you opted for this, and by the time batch is starting, maximum within 1 fortnight, if the data is not already shared, we can allow that migration. However, at very later stage, it will not be possible, because there are certain strict norms and regulations we have to adhere to for the program to be aligned to them. And as I said, the initial journey from the very basics to intermediate and to advanced is gradual and with good coaching. So there is not very strong reason why you may have to go for this. That's where I said you might have to consult with the counseling team and discuss your particular use case, background, and profile. But by and large, the objectives and the backgrounds we get, there is not much motivation to stick to business analytics 360. And I feel little pain in saying that, because for very long, this used to be a very popular course. But as the data science industry evolved, right, and the kind of expectations which are from the professionals, that basically makes data science 360 much more relevant program from employability point of view.
Hello, good evening, sir.
Yes, good evening.
This side, but this sir. So I have a query about the data analytic course, sir. If someone is having go for the data analytic course, then what would be good for them?
See, for data analytics course, this name business analytics, if I change the name data analytics 360, right, it's the same thing, right? So if you're specifically targeting role as a data analyst, right,
Yes,
you can go with this course, right? But again,
I think
probably I'm not able to make that point clear. Whatever skills you are learning here,
yes, sir,
right, you're going to learn here also. However, this is coming up with a much more powerful and government-backed certification and support. So that's a point I'm trying to make. But yes, if you're specifically targeting only a data analyst role,
yes, sir.
then this is the course you can opt for.
Okay, so you mean to say that business analytics is come across same like data analytics?
Correct. Because from skills, learning, and what you ought to face in the interviews and the job role, this is same.
Okay, sir. Okay.
And across the industry, you would see that term is also very interchangeably used.
Yes, sir. Yes, sir. I have gone through this also.
Yeah. Okay.
So, sir, if anybody wants to opt for a data analyst or business analyst or analytics consultant role, then for that person, the business analytics 360 would be a perfect course, right?
No. So let's say, if I understood your question completely, so let's say someone who wants to play this kind of role. Sorry, have I understood correctly? You mean to say if someone is targeting this kind of role?
Yeah, if somebody wants to play the role in the field of analytics, but not completely into machine learning or AI, in that case, is that course sufficient?
See, that course would be sufficient. But in that case, this definitely you may not go for. Why this will be still a choice? Because as a analytics consultant and machine learning, business consultant, you need to have few things as part of your skill set. One, in what kind of problem area, what kind of analytics technique will be used. If that does not work, what are the alternatives, right? In what situation simple statistical model will be more beneficial versus machine learning or vice versa, right? So as a business consultant, you may not be doing those things day in, day out. However, to guide your teams and you to guide your client, that what are the possibilities, because let's say tomorrow your client says that, okay, they have an NLP project and they want some help to make a chat bot. Now you need to have some understanding that how much data or what type of data we need to make a chatbot effectively, and how much time your team may need for it, right? So the difference is, it will solve a problem if you know that your work, your organization or client is always going to stick to basic analytics applications. However, let's say you're in a consulting domain, you are into a client services domain, where clients sometimes may have most of the time basic problems, but sometimes they may have complex problems, and there is a possibility the solution to their problem may go through machine learning model. So in those cases, we suggest, and the answer was very different 3-4 years back. The answer is very different now. There was a time, as I said, this was the most popular course because this used to suffice. But now, not working on machine learning model is perfectly fine in most of the job roles, if you're playing a leadership or consultant role. But at least understanding the possibilities, solutions, and limitations that is expected from that job role also. So basically, that's why you may not go for this where you are going in depth into data engineering and AI side of it, but at least this much is going to be much more recommended.
Okay, thank you.
Okay, so guys, I'll stop here. I have my colleague Sabrish, and I think Shaz should also be here. Sabrish, do we have Shaz also?
Yes, Shaz is there.
Yeah, hi Shaz, good evening. So guys, Sabrish and Shaz will take care of rest of the session, where they will spend few minutes in explaining about the learning management system, how does it work, and some other queries which you had about the upcoming batch or the timings, etc. Right? Any question on the advanced side which I was not able to answer, or you could not get time to discuss that, you can connect with the counseling team. I'm very happy to schedule one-to-one call with you guys. If you have any personal or let's say the one-to-one things to be discussed regarding your profile. Sure, thank you. I hope the session was useful and you found it informative.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.